Welcome back. Before going into the details of the zeroth law, let us look at another state postulate. Let us call this state postulate 2. The state postulate 2 defines the number of properties which are needed to uniquely define the state of a given system. State postulate 1 told us that state of a system can always be defined using primitive property. It is not necessary to do so, but it is possible if you want to do it. But it does not tell us the number of properties which are needed. What state postulate 2 says is that the number of independent intensive properties required to define the state of a system is the number of two-way work modes plus 1. So, in words, the number of independent intensive properties required to define the state of a closed system is number of two-way work modes plus 1. And by closed system we mean a system of fixed mass, because mass cannot enter or leave such a closed system. So, this means in symbolism, number of properties required is number of two-way work modes plus 1. So, now let us look at the consequence of this. Let us say that we tabulate number of two-way work modes. If we have a simple system, the number of two-way works modes would be 1. If it is greater than 1 or greater than or equal to 2, we have complex system, whereas if it is 0, then we have a rudimentary system. So, by the state postulate 2, the number of properties required would be 2 for a simple system, 3 or greater for a complex system, and exactly 1 for a rudimentary system. Now, it is interesting to know that for a rudimentary system, number of two-way work modes is 0. This implies that exactly one property is needed. Now, the question that comes up is, which property could this be? Can we have a single property applicable to all rudimentary systems? These questions lead to the concept of temperature, and for that the thermodynamic vehicle is the zeroth law, to which we will now turn. Thank you.